Hi guys, so today we're going to be learning about adding and subtracting rational expressions. Because rational expressions are essentially fractions, we're going to be talking again about least common multiple, because when we add and subtract fractions, we need common denominator. Okay, so we're going to start off with finding the least common multiple of several of these monomials, basically. Okay. So the first thing we're going to look at is our coefficients. So here we have 18r squared s to the fifth, 24r cubed s and t squared, and 15s cubed t. Okay. So for each of these, we're going to break it down into its factors, right? So 18r squared s to the fifth. Okay. If we do a factor tree for 18, it's 2 and 3 squared, right? So 18 is going to be 2, 3 squared, and then we have r squared, and then s to the fifth. And if you want, you can write it all out, but essentially there's no need for that. Okay. Next one here is 24 r cubed s t squared. Right? So if we were to do a factor tree for 24, 4, 6, we have 2, 2, 2, and 3. So that would be 2 cubed times 3. And then we have r cubed, s, and t squared. Right? It's a little blurry. Okay, there you go. And then 15s cubed t. No need to do a factor tree, hopefully, for that one. 15 we know is 3 times 5. And then we have s cubed here and t. Okay. Okay. So here we want our least common multiple. Okay. So first, let's look at our 2's. Okay. So here we have 2 to the first, 2 cubed. So this is the smallest amount, or the biggest amount here. So we want 2 cubed from that list. Okay. Then in our list of 3's, we have 3 squared, 3 to the power of 1, 3 to the power of 1. So we want the 3 squared one. Right. Then we just have some random singular 5 by itself, and others have 5's. Okay, looking at our r's, we have r squared, r cubed, so r cubed is more, right? Then looking at our s to the fifth, s and s cubed, circle it, s to the fifth is more. And then t squared and t squared is more, right? So then our least common multiple is everything I highlighted. It's going to be 2 to the third, my 3 squared, the 5, the r to the third, s to the fifth, and t squared. Okay, so then the variable part is easy. We just need to do this. So 2 cubed is 8. 8 times 9 is 72. And then 72 times 5 is 360. And so our least common multiple is 360, r to the third, s to the fifth, t squared. And there you go. Okay. So why don't you try CYP1A, and once you're done, come check your answer. Okay, you should have gotten 108, a to the fifth, b to the fourth, c to the third. If you got that right, you can move on to example 2. If not, here's your explanation. Okay. So I did the prime factorization for each part. 12 is broken down into 2 squared times 3. 27 is 3 cubed. 18 is 2 and 3 squared. Okay, then looking at each of the factors. So of the 2's, 2 squared is the biggest. Of the 3's, 3 cubed is the biggest. Then a to the fifth, b to the fourth, and c cubed. Okay. And I just multiplied them all together. 2 squared is 4. 3 cubed is 27. So 4 times 27 gave me the 108. Okay. And then a fifth, b 4, c cubed. Okay. So now we're going to do the same thing. We're going to be doing the prime factorization. This time though, they are polynomials. Okay, so we're just gonna do the same thing where we did prime factors, we're gonna factor these as well. So here I have p cubed plus 5p squared plus 6p. Okay, so I can pull out a p. Okay, then I'm left with p squared plus 5p plus 6. Okay, and then that breaks down into p plus 2 and p plus 3. So this is me factoring it. Alright? Then I have p squared plus 6p plus 9. So p squared plus 6p plus 9. So this becomes p plus 3 squared. Okay. So then, again, I want the least common multiple. So here I have a p. Then I want p plus 2. Okay. And then p plus 3 compared to p plus 3 squared, I'd want this one. Okay. And so then my LCM here is p plus 2, p plus 3 squared. There you go. Okay, why don't you try CYP2B, and then once you're done, come check your answer. Okay, what you should have gotten is K, 2K plus 3, and K minus 4 squared. Okay, so all I did is I factored them, and then found the greatest one of each. Okay, 2K plus 3, K minus 4 squared. Okay. Okay, so now the reason why we need to find least common multiple is because when we're adding, we want common denominator. Okay, so here, as we're adding 7x over 15y squared plus y over 18xy, what we need is we need the common denominator, right? So 15y squared, right, is 3 times 5 times y squared. 18xy is 2 times 3 squared xy, right? So here, the least common denominator is going to be 2 times 3 squared times 5 times xy squared, okay? And this is going to be 2 times 9 times 5, 90 xy squared. Okay, so the reason why we need least common multiple, the reason why our first two examples dealt with that, is so that way we can find what the least common denominator is. Okay. So now, to make 15y squared into this, I need to multiply this by 6 and an x. And so to balance it out, I'm going to multiply this top by 6x. Okay. Then for this, I need to multiply this by a 5 and another y. So multiply this by 5 and another y. Okay. 6x times 7x is 42x squared. Okay. And then now this part is our common denominator. This will be 90xy squared. Okay. This becomes 5y squared. And then now we have our common denominator of 90xy squared. And when we're adding fractions, once we have our common denominator stays the same. Okay. And then the top we just added. In this case, there are no like terms, so it would just stay as 42x squared plus 5y squared all over 90xy squared. And there you go. Yep. So why don't you try CYP 3C and 3D and come check your answer when you're done. Okay. If 3C, you should have gotten 10 minus 9x squared over 15xy. In 3D, you should have gotten 18AC plus 14BD divided by 21AB squared. If you got that right, you can move on to example 4. If not, here is your explanation. Okay, so common denominator for this should be 15xy. Okay, so to make this 15xy, I multiply 5 top and bottom. That gives me 10 over 15xy. To make this 15xy, I need to multiply by 3x top and bottom. 3 times 3 is 9, x times x is x squared, and then 15xy. Then denominator is the same, so I keep the denominator, and then it's just 10 minus 9x squared. No like terms, so it just stays as it is. Okay. 3D here, the common denominator is 21ab squared. So to get this to be 21ab squared, I need to multiply 3a top and bottom. 3 times 6 is 18, a times c is ac, and then 21ab squared. To get this to be 21ab squared, I need to multiply by 7b. Okay, so 2d times 7b would be 17bd, or db, up to you. 14. And then this is 21ab squared. Denominator stays the same, then it's just 18ac plus 14bd. No like terms, so nothing to combine or simplify there. Okay, so now what happens if it's a polynomial? Okay, so here what we're going to do is we're going to factor. Okay, so then here I'm going to factor. This becomes w plus 12, nothing to factor there. This is 4w minus 4, right? Minus, this is w plus 4, and then this is 2w minus 4. Okay, so the denominators are pretty similar. The only difference, right, is that this is a 4 and this is a 2, right? The coefficient kind of is different. So I just need to change this to be a 4, so I can do that by multiplying by 2, and so I'm going to multiply this by 2. Okay. And so what ends up happening is I have w plus 12 over 4w minus 4 minus, and I'm going to distribute this 2 now, 2w plus 4 over, now it's going to be 4w minus 4. Okay. So then really this negative becomes negative 2w minus 4. Right? So w minus 2w is negative 2w. 12 minus 4 is 8. Okay. And then here on the bottom, we have 4w minus 4. Okay. I'm going to factor out this negative 2. So negative 2, then this becomes w minus 4 over 4w minus 4. Okay, these can simplify, and then negative 2 over 4 is just negative, sorry, something happened, 12, hold on, give me a second, oh, my bad, sorry, here, this should be 2w, and then this should be plus 8, right, so this would be minus 8, and so then w minus 2w is negative w. Okay. 12 minus 8 is negative 4. Right? We're going to factor out the negative 1, which will leave which will leave us with w minus 4. Those cancel out, leaving us with negative 1/4. Okay, there you go. A little messy there. Okay, why don't you try CYP4B, and then once you're done, come check your answer. Okay, you should have gotten as the numerator negative, and then quantity of x minus 3, quantity of x minus 1, over 4, quantity of 3x plus 5, and quantity of x plus 1. Okay. If you got that right, you can move on to the next example. If not, here's your explanation. Okay, so I factored this to be 3x plus 5, x plus 1, and factored this to be 4 and 3x plus 5. So least common denominator would be 4, 3x plus 5, and x plus 1. So for this one to be that way, I had to multiply top and bottom by 4. For this one to be that way, I had to multiply top and bottom by x plus 1. Okay. So then here this becomes 4x minus 4. Okay. And then this becomes x squared minus 1. Distribute the negative, so negative x squared plus 1. Combined like terms, this becomes negative x squared plus 4x. Negative 4 plus 1 is negative 3. Okay. And then meanwhile, my denominator has changed to my least common denominator now. Okay. And then I just factored it the rest of the way. So factored out the negative 1. And then factored this to be x minus 3, x minus 1. There's nothing to cancel or simplify, so then I just left it in factored form. Okay, so now, similar to before with complex fractions, we are going to simplify these. Okay. So for now, we're going to deal with the complex fraction. So we're going to deal this as one group and this as another group. Okay. So here the LCD is xy. So to do that, I'm going to multiply this by y and this one by x. Okay. So then on top, basically, I will have y over xy minus x over xy. Okay. On the bottom one here, this is technically over 1, so I need it to be common denominator as well, which in this case is x. So this then becomes x over x plus 1 over x. Okay. So this becomes y minus x over xy, and this becomes x plus 1 over x. Okay. Okay, and then, since this complex fraction, it's this fraction divided by this fraction, I'm going to rewrite it in that way. So y minus x over xy divided by x plus 1 over x. Okay. We're going to flip it, change, so keep the first fraction. Flip the second one, so x is now on top, x plus 1 is on the bottom. We're going to change the division to multiplication. Okay. The x here and the x here cancels, and it leaves me with y minus x on top and y times x plus 1 on the bottom. Right. So you can leave it this way, or if you really want to multiply it back in, it would be yx plus y, or xy plus y. Okay. Either way, it works. Okay. Okay, so why don't you try CYP 5A and 5B and come check your answer when you're done. Okay, for 5A, you should have gotten x plus y over x minus y, and for 5B, you should have gotten a times a plus b over b times a minus b. Again, if you want, you can distribute it, but there's not really a point in this case. Cool. Okay, so if you got that right, you can move on to our last example. If not, here is your explanation. Okay. So here I need common denominator that will be xy, so I can get that by multiplying top and bottom by x, and that's x over xy. For this one, multiply top and bottom by y, and that will be y over xy. So that will be x plus y over xy. Okay. Similar thing here, to get this one to be xy, it will be times x. To get this to be y, it will be times y. So then this will be x over xy minus y over xy. So that's why it's x minus y over xy. Okay. So it is this divided by this. So this divided by this. So then keep the first fraction, flip the second one, so that's why xy is on top now, and then change the division to multiplication. Xy's cancel, leaving me with x plus y, x minus y. Okay. Here's the next one. So here, common denominator is b, so top and bottom multiplying by b, so that's why it's a plus b over b. For this, common denominator would be a, so multiply top and bottom by a, and that's why it's a minus b all over a. Then this complex fraction is this, divided by this. Okay? So then to divide, keep the first fraction, flip the second one, so that's why a is on top now, a minus b is on the bottom, and change the division to a multiplication. Then I just multiply across, so a plus b times a, and b times a minus b. And there you go. Okay, so the last part here is using a complex fraction to solve a problem. So here it is asking to find the slope of the line that passes through A, which has this coordinate, and B that has this. Okay? So if you remember your slope formula, it is y2 minus y1 over x2 minus x1. Okay? So all I'm going to do is make one of these x1, y1, and the other one x2, y2, and plug it into my formula. So m equals, we're going to do y2 minus y1, so 3 over p minus 1 over 2, right? y2 minus y1 over x2 minus x1, so 1/3 minus 2 over p. Okay? We're going to need some common denominators. So for this one, common denominator is 2p. I'm going to do that by multiplying top and bottom by 2 here. And to get this to be 2p, I'm going to multiply top and bottom by p. Okay? Here, the common denominator will be 3p. I'm going to change this by multiplying top and bottom by p, and this one top and bottom by 3. Okay? So then, I will end up having 2p as a denominator for the top fraction. So 2 times 3 is 6, minus 1 times p is p. Right? So 6 minus p all over 2p. Okay? For this one, the denominator is 3p. Right? P times 1 is p minus 6. There you go. Okay. Then, this complex fraction, it's this divided by this. So I'm going to rewrite it as 6 minus p over 2p divided by p minus 6 over 3p. Right? So dividing fractions, we keep the first one, we flip the second one, so now 3p is on the top, p minus 6 is on the bottom, and we change the division to multiplication. Okay? So here, I noticed that I could factor out a -1 to kind of make it match this, right? Because it's pretty similar, just opposite signs. So that's what I'm going to do before I simplify anything. Right? If I factor out a -1, right, this becomes negative p plus 6, or using the commutative property, I can do 6 minus p. Now it's easy to cancel. So this and this, p and p, and so then on top it's just 3, and the bottom 2 times -1 is -2, and so the slope is -3/2 here. Okay. So why don't you try CYP6A, and once you're done, come check your answer. Okay, you should have gotten -4/5. If you got that right, you can move on to the homework. If not, here is your explanation. Okay, so again, finding the slope. So I'm going to use the slope formula. So m equals y2 minus y1 over x2 minus x1. Right? So here for the fractions, since I'm subtracting them, I need common denominator. So common denominator for the top part is 5q, so that's why I'm multiplying both of these by q, and multiplying both of these by 5. So that's why it becomes q minus 20 over 5q. Okay. For the bottom part, common denominator would be 4q, that's why I'm multiplying these by 4 and these by q, so that will be 20 minus q all over 4q. Right? So this complex fraction is this divided by this. Okay. Then I changed it, so it's keep the first fraction, flip the second one, so that's why 4q is on top now, and then change the division to a multiplication. Okay. And then again, I noticed a similar pattern with the q minus 20 and the 20 minus q. So I can factor out a -1. That will give me -20 plus q. And then I can rewrite it using the commutative property to change it to be q minus 20. Okay. Then the q minus 20s cancel out, leaving me with just, and then the q's cancel out here, leaving me with 4 on top and 5 times -1, which is -5 on the bottom. So that's -4/5. Okay. That's it for today. Have a great rest of the day. Bye, guys.